Okay, well, clearly problem number 21 is worded a little strangely. So let E be the solid that lies under the cylinder. Really, that should be inside the cylinder. Inside the cylinder, x squared plus y squared equals 9. Above the plane, z equals 0, and not below that cone. Oh, that cone. But below the cone, z squared equals 4x squared plus 4y squared. Okay, and we want to do this integral. So let's think about this. It is the solid that lies inside the cylinder, x squared plus y squared equals 9, above the plane z equals 0, and below this cone. Okay, so let's look at what the projection, let's look at kind of, not really the projection, but what the cross section of this would look like in, let's say, the xz plane. So let's say this is x, and let's say this is z. Well, the cylinder, these vertical lines represent the cylinder. Actually, I want to change this to red. These vertical lines represent the cylinder. Okay, this is what a cross section of a cylinder looks like in the y equals 0 plane. Okay, z equals 0 would be this part right here, and in the cone, z squared equals 4x squared plus 4y squared. That's the same as z is equal to 2 times the square root of x squared plus y squared. So it's going to look something like this. Again, this is the cross section. Okay, and the region that we care about is this part right here. So really, this is a 3D region. Just imagine spinning this region on the z-axis, and this is the region that we're interested in integrating over. Okay, so we're going to want to use polar coordinates. So x is equal to r cosine theta, y is equal to r sine theta. So the symmetry of the problem, just the way the problem is set up, says that for every indicates that for every x and y value, we should integrate in the z direction. Okay, something like this. We're going to go from the bottom here to the top. So we're going to go from z equals 0. So if I solve this for z, this says z, actually let me put that in another place. This says that z, let me just write it up here really quickly. Z is equal to 2 times the square root of x squared plus y squared. But in polar coordinates, that's just z is equal to 2r. So z is going to go from 0 to 2r. Okay, now we have to figure out what the r limits should be. Well, again, if we project this shape onto the xy plane, it's going to be a circle of radius 3. 3 because it's a cylinder of radius 3. So we're going to have r goes from 0 to 3. Okay. And then theta will go from 0 to 2 pi. Okay, and again, that hieroglyph is z. So now I also erase the integral sign. Okay, and now since we are in polar coordinates, we're always going to write the r dz dr d theta, and the function that we're integrating is x squared. So in polar coordinates, that's r squared cosine squared. So this is r squared cosine squared theta. And this is 486 pi divided by 3. Whoops, that is not right. Divided by 5. Okay, again, I'm going to say this one more time. I know you're probably driving me crazy. This is a tedious integral, but again, a straightforward one. The hard part is going from the problem description to this part right here. Okay, so now we're going to do this one. Again, we want to do cylindrical coordinates, and let's just try to do this all at one shot here. So what's happening here? So we want to say x is equal to r sine theta and y is equal to r cosine theta. Sorry, x is equal to r cosine theta, y is equal to r sine theta. So this says that z is going to go from the cone, z is equal to r in polar coordinates. This is r, z equals r up to 13. And then in the xy plane, what's happening is this says x is going to go from the left half of the circle of radius 9 to the right half of the circle of radius 9. And this says y is going to go from -9 to 9. So the x and y integrals tell us that we're integrating in the xy plane, that region. The projection of this shape on the xy plane is going to be a circle of radius 9 centered at the origin. So in polar coordinates, or cylindrical coordinates, z is going to go from r to 13. And let me just write explicitly what we're doing, since I haven't drawn any pictures for this problem. I'm just saying x is equal to r cosine theta and y is equal to r sine theta. Okay, and so z goes from r to 13. R is going to go from 0 to 9. And theta will go from 0 to 2 pi. Okay, and now don't forget the r dz dr d theta. And the function that we're integrating, don't forget that, that's x times z. Z is just z, so this is going to be r cosine theta times z. Okay, and the answer to this is 0. One way you can see that even before switching to polar coordinates is that once you do the z integral, you're left with an x integral, and the function of x is going to be odd, and you're going on minus something to positive something, symmetric limits, so it's equal to 0. Anyways, or you could just do this integral and see that it's equal to 0, whatever way you want. Okay,